Today my very important topic to all of you, Born approximation. Very important topic. You have studied in last video partial wave analysis. Partial wave analysis is applicable for the low energy incident particle and spherically symmetric potential particle only. But Born approximation is used to calculate the scattering amplitude if scattering potential is very weak. If scattering, the target potential is very weak and incident particle have large energy. पार्टिकल की बीम जो इंसिडेंट होने आ रही है, इट हैज लार्ज एनर्जी and target have weak interaction. Interaction applied by the target is weak and incident particle beam have low energy. In such case, you can use Born approximation. In this topic, the solution of Schrodinger equation must be noted directly. It will be learned from the topic of derivation of Schrodinger equation solution. Schrodinger equation solution for two-body scattering problem. Its value is asymptotic solution is given by this, where psi r is the wave function after scattering and psi r dash is the wave function before scattering. And scattering amplitude part is this. This part is the scattering amplitude part. E to the power I k r upon r. मतलब हमारा जो फार्मूला होता है e to the power I k dot r और प्लस f theta e to the power I k r upon r. So f theta is equal to this. Born approximation have many order of approximation. In zero order approximation, you will assume psi r dash, because according to this equation, scattering amplitude can be calculated if we know the wave function. K is the propagation vector along this direction and k dash along this direction. Their resultant is along this direction. This can be assumed as q. So k minus k dash is assumed as a q. K minus k dash h cross is equal to q h cross. Momentum transfer by the incident particle to the scattering potential. In other words, change in momentum q h cross due to collision. Kh cross is the momentum of incident particle. K dash h cross momentum of scattered particle. So QH cross is the transfer of momentum from incident particle to scattered particle. It is scattered potential. QH cross is equal to K minus K dash H cross, where Q is given by this. K minus K dash is replaced by Q, so it will becomes this. K minus K dash को Q लिख दिया गया है. D tau dash is R dash square sin theta d theta dash d phi dash dr dash, and the limit of phi is 0 से 2 pi and theta is 0 से pi and r dash is 0 से infinity. So put the value in integration. फाई को 0 से 2 पाई तक इंटीग्रेट कर दीजिए एंड थीटा को इंटीग्रेट करने के लिए कॉस थीटा डैश को x मान लीजिए. कॉस थीटा डैश को x अज्यूम कर लीजिए तो साइन थीटा डैश माइनस साइन थीटा डैश डी थीटा डैश dx हो जाएगा. सो 0 से पाई इस इंटीग्रल को ले लीजिए, इसमें थीटा को x में कन्वर्ट कर लीजिए और जब आप इंटीग्रेट करेंगे तो यू विल गेट वैल्यू ऑफ दिस 2 sin QR dash upon QR dash. Substitute this value in this integral 0 to pi in this integral. So f theta is equal to this term where you have taken validity of Born approximation. In the Born approximation, psi r dash was replaced by e to the power I k dot r dash, where r dash is the position vector of source point, which is valid only if scattered wave function is very small compared to plane wave. The psi s scattered wave function is given by this and psi r dash is taken as e to the power I k dot r dash. They are mod very less than 2 1. If we use spherical polar coordinate, so volume element d tau dash is equal to r dash square sin theta dash d theta dash d phi dash dr dash, then this equation becomes this equation. ur dash is equal to twice mu vr dash upon h cross square. अब according to this equation, for their validity, this term is very less than to 1. In this way, sin kr dash, if the energy is high, then sin kr dash will be rapidly varying function and value of integral will be very small. If energy is high, k is high, then sin kr dash has a varying function, rapidly varying function, and integral will be very small. In case of weak potential, Vr dash is very small, this term is smaller than 1. Hence, Born approximation is valid for weak potential at high energy. So for the validity of this equation, sin kr dash must be rapidly varying function, so k energy should be large. If energy should be large, then this term will be small. And for this term will be less than to 1, Vr dash potential is very small. So potential factor will also be very small, 2 mu upon kh cut square. So for the validity of Born approximation, incident particle must have very small energy and interaction potential is also very small. Incident particle must have very large energy and interaction potential will be small for the validity of Born approximation.